I've got an extra sheet of paper. I advise you, if you want to really show all your work, do like sprawl out on this test, get some extra paper, and you can do your work elsewhere if you want. I'll give you more space than this too. I was trying to conserve paper when I made this. So we've got a car traveling with a velocity of 21 meters per second, and it slows down to 15 meters per second. So here's my car, and it's going 21 meters per second, and then this is a lot like the one we just did on the quiz. And then it slows down to 15 meters per second, and the time, delta t, is 3 seconds. This is very much like that. We just have to find acceleration. So instead of making my really long list, I think I'm going to make a shortened list right now. In fact, this, maybe I'll make a longer list. This is V0, and this is V. So initial velocity, final velocity, change in velocity. And if I'm looking for acceleration, there's really only one formula for that. That's this one. So acceleration is just change in velocity over change in time. And I've got the change in time. That's 3 seconds. I don't have change in velocity, but it's easy enough to get. Change in velocity is just the final velocity, 15, minus the initial velocity, 21. So that's -6 meters per second. -6 meters per second divided by 3 seconds is -2 meters per second squared. So if you had +2, you'd lose a little bit. I don't think I'll end up taking half of it off. I'll probably take off about 1/4 on the test. And if you don't have meters per second, you'll lose at least 1/4 of a point there. Any questions about that one? So on the test, you could expect something like this, except it might be speeding up. It might be going from 15 meters per second to 40 meters per second, or it might be going left at 5 meters per second, and by the then it's stopping over here, and the amount of time might be different. Or maybe you're given the acceleration, you have to find the time. Now the ball dropped from a high place. This is the one people were saying, you're not giving us numbers. Well, you've got one number, and you can come up with another 2 numbers. So draw your picture. Here's the ball, and it's going to fall for 5 seconds. And it doesn't have to hit the ground. I'm just going to write delta t equals 5 seconds. So we could assume it's almost to the ground then. So I have 2 more bits of information that aren't given. I'm going to write all the things over here. V0, V, average velocity, change in velocity, acceleration, time, and delta y. Why am I writing delta y now instead of delta x? Anybody? What's that? But why am I using y instead of x? I used x on the quiz. And I used, I don't know if I used x on the previous one. That wasn't even really part of it. Does anybody know? This is a good way to describe displacement here. But in this one, I would have written delta x for displacement. Come on, somebody? Yeah, because it's vertical. This is in the y dimension. This is on the y-axis, and this is on the x-axis. So the position on the y-axis, we use y for the symbol. And on the x-axis, we use x. So that's why I'm switching here. I don't really care if you switch, but I'm just explaining that to you. Okay, so I know delta t is 5 seconds. What else do I know? I know 2 other things here. Do I know the initial velocity? I do. Yeah, 0. How do you know the initial velocity right here is 0? Are we throwing a ball from a high place or just dropping it? Dropping. If you drop something before you let go, how fast is it going? 0. So file that away in your brain. If this is asking about something dropped from a high place, then it starts at 0. Do we know the final velocity? Like, no, because it's gonna. Well, let's get rid of the ground, because that confuses people. Do we know the velocity here? I'll put the ground there. So it falls for 5 seconds from there to there. Do we know this? Oops, sorry. No, it's not given anywhere. And we could find it. Do we know the average velocity? Like, as in, are we told the average velocity? We're not told it, and it's not really obvious. How about change in velocity? Yes or no? Nope. Acceleration. We are told the acceleration. And here's where you're told the acceleration. It free falls. So that tells us the acceleration is what? 9.8 close. Negative 9.8. So the acceleration is negative 9.8 meters per second squared. So those are the two hidden things that you're actually told. And that's enough. That's enough to find everything else. What am I looking for finally? How fast is the ball traveling after 5 seconds? So just get out my formulas here and start thinking about things I can find. So how fast it's traveling after 5 seconds? Let's talk about which one of these symbols would be that answer. We're looking for the speed when it gets to here. Are we looking for V, average V, delta V, or delta Y? Which one are we looking for? What's going to be the speed after 5 seconds? If we can't answer this question, we can't get it. Nobody knows? I'm going to pick people. I think you know. I think you just need me to harass you individually. Okay. Max, do you know? The symbol that represents this. We're trying to find out how fast it's traveling. What? V, yes. So we've got the final velocity, the V, this is the speed after 5 seconds. That's the one we want to find. So we could look for a formula that just has that in it. And the only ones with that in it are this one for delta V. It's got plain old V in it. And then either one of these, depending on how things are set up. We could use either of those formulas. So, I don't know, one way to do it is just to see if we can do this. In order to use this, I need delta V and I need V0. But I don't have delta V and V0, so this one won't work. In order to use this, I need average velocity and I need V0. And I don't have average velocity and so I'm just going to have to find some other stuff before I can do it. So I do have A and T and V0. I can't use this formula, and I've already found out I can't use that. Let's see, this one's the only one I haven't checked. So with this, I can do it. I've got A, and I have, oh, wait a second. I don't have delta V. Oh, wait, I can find it. I've got A and I've got T. So we have A and T, we can find delta V. So I'm going to cover up delta V. My formula is just A times T. So delta V equals A times T, and A is negative 9.8, and T is 5 seconds. And I've done this enough times to know that if you multiply 5 times 9.8, you get 49. Negative 49 meters per second squared, or per second, is delta V. So negative 49 meters per second. Where did I get it?
Yeah, like how'd you get these so high?
You just have to know. So
Yeah, but like how'd you get that from just the time being 5 seconds?
no, I didn't. I got that from this saying that the ball's free falling.
So it's just you have to memorize that.
You have to memorize that. That is the acceleration of gravity. Nope, there's no equation. That you just memorize.
All right.
So anytime you have something about a ball being dropped or thrown in the air, this is the exact acceleration. I might be kind and I might say, let's just round off to -10. But if you get a problem like this with no other information, assume the acceleration is -9.8.
It's always just linear measuring.
Yep. So now that we know the change in velocity is -49, we can find final velocity. I mean, we could just find it all here, but this I think we can do, because now I have the change in velocity and I had the initial velocity, so I'm just going to use this formula and plug stuff in. So I'll rewrite the formula. Change in velocity equals v minus v0. And the change in velocity is -49. And the final velocity, that's what we're looking for, is v. v0 is 0. So v minus 0 equals -49. What is v? -49. -49 meters per second. So that's sort of the answer. Well, first, the answer to A is -9.8 meters per second squared, and the second one is -49 meters per second. Really, though, I'm fine with this answer, but really, if you're asked how fast, is that asking for velocity or speed? I would say 49 would answer somebody's question better. If you say -49, they'll look at you twice. But -49 is the velocity because it's going down. 49 would be the speed. Okay, so now try number 9. This is, I'll warn you on this. I'll make this simpler on the quiz. The time interval between each of these dots is how many seconds?
1.
No, between the dots.
2.
It's 2 between the dots. So just keep that in mind. That means like the amount of time between this and this